Hey, at least I remembered to turn on the recording. Okay, let's see here. This is a brake bracket I've got designed, and this is Fusion360. Most people will recognize it if they're watching this. It's really cool CAD/CAM software combined. What I want to do is partly for my own record, so that as I change stuff and everything, I can come back and refer to this. I don't have I have screen capture software, I just don't have a microphone. The microphone on this laptop doesn't want to work, so what I'm going to do is I want to run through pretty much how I have all this set up, and it might benefit some noobs, some beginners or early amateurs, you know, like myself with this stuff. I've run this part a couple of times, and I'm getting ready to run it again because I messed up the last one. So let's see, where do we start here? Now, setup 1, you can't see it, I'll turn them back on here. These are the soft jaws. Okay, now that's for operation 2, but the first thing I did was go ahead and create them because I wanted to make new soft jaws for the rest of the parts, because I didn't really care for the first ones. And if you see here, I added some nice radiuses, and so it doesn't leave any marks on the part when I clamp it in. Okay, and I may turn those back on when well, just for reference here, let's look at it from the front, and you get an idea about how much is sitting up there. Then you can look underneath there and see that they're mated in nicely. Okay. So let me just turn those two off. Whoops, wrong one. There we go. Oh, that's because I'm on setup 1. Let's go to setup 2. There we go. So, setup 2. Make it active just for the heck of it. This is the chunk of aluminum, okay, which is, that's what it's starting out at. So the first thing I want to do is face it. Okay, now for my reference, or not for my orientation, I have it set right here in the back left corner. Okay, and actually if I turn the jaws back on, well, it's kind of hard to see them. I have a step cut in. Okay, and so when the block starts out, it sits in that step and it's oriented to that corner. Now granted, these are upside down right now, but just to give you an idea, that's what that reference point is, because it's very easy for me to measure that and then to set the block in, because it sets into the notch and I can just put it up flush with the left edge. And that's the everything is based around the soft jaws, the fixed jaw, so I don't have to so when I flip this thing over and it nests into those cutouts on the soft jaws, it's still, everything is still referenced just fine, and if something happens, I can still come back and reference that step in the jaw. Okay, you know, if I pull the part out and put it back in, I can reference that and not have to go find a hole or something like that on the part here. Okay, I don't want this to take hugely long, but so here's the facing. It's one facing operation. And if we look at the stock, you can see there's a carrier, enough here down at the bottom for a carrier, and it's more than the step in the jaws. The step in the jaws is only 1/8 of an inch. Okay, and then as you zoom in here, you can see that there's the stock and there's the part. So if we go in here and we edit this, oh, and I saw something this morning on something. Ah, if you double click on the icon, you don't have to right click and select edit. Interesting. Okay, so I'm running, this is my Tormach Superfly with that aluminum cutter in it, the polished one. I'm running 2500, 6 thou per inch, which works out to 15 inch a minute cutting rate. The geometry, it automatically selects that as the for the top there, whatever. Well, let's look at that. Let's turn it at an angle and look at the geometry. Okay, I selected that chain because otherwise it went to the I guess I don't have to select that actually. The difference here is that bottom height is model top, top height is stock top, so it knows that where the top of the stock is, so it's going to take a 20 thousandths cut and come down to the model top. Because in my, I guess I kind of glossed over the stock setup, didn't I? I have it set here, it's a milling operation. The stock box point, I have it selected back there in that back corner there, the body, the stock. So here's what I'm looking at. The center, left and right, back and forward, they're X and Y, they're centered. But for the Z, I have it offset from the top by 20 thousandths, and that's what puts the part 20 thousandths below the surface for that facing cut to take that off. I could make that 10 thousandths, but on a couple of these pieces they were cut with the bandsaw, and I'm not sure that 10 thousandths would clean that up perfectly. So that's why I've got to set it 20 thousandths, and hopefully that's enough. I might just have to make it more, but the next block I'm running is only 1.4. Everything else is like 1.45, so there's a 50 thou difference, so I could actually put more in here, but I probably should. Well, I know this one going in is I have to change it for the other. Anyway, I'm rambling, blah blah blah. So let's change that. So now I go in here to post-process, and I actually name this because then that name sticks with it as I do the post-processing and saving it and putting it in a Dropbox and everything. Okay, and I also went in here for the program comment, and I don't know if this is just what I'm doing. Orient back left of step jaw, stepped fixed jaw, or back of step fixed jaw. So that lets me know that orientation, that's what that's going to do. That's going to sit back in that step of the jaw and be all the way to the left. Okay, so then we kind of covered the face already. A couple things I also changed here is I put the stock offset at 1 inch because it's not going to show me here, is it? Because what was happening was it was starting down here, and it was running one of the cutter marks right across the hole. Yeah, I think you can see here. So if you end up with any kind of step or anything, that's not where I would want it. Now granted, this is my mounting surface on this side, so it's not that big a deal. But when facing this side, I needed to worry about it more. Yeah, see, and it did it on this one too. So Well, hell, we better do let's do a little simulation here. Okay, and now we can see that the edge of the cut is right here instead of going across the middle of the hole. Now, granted, the hole I showed you was the one on the backside, so we'll have to look at it for that. But and you can change your step over. It's a 3-inch cutter. I think the 285 was is 90%, 95%, and that's set. You can change it, but and then you can change these if you want. Not really necessary. Sometimes you will want the cutter to run all the way off and not, you know, not turn while it's still on the piece. And I've had to adjust it a couple of times for that. On a, I think it was a different part, but okay. So here's one of the primary operations, cuts, whatever. And it's kind of hard to tell there, but if I show it from the front, okay, you can see the shelf. Now this has a step down of 0.75, and I got it to separate so that it cuts that shelf separately, but it's all in this same operation. That it is a it's a 3D adaptive. Now if you look real close at the bottom here too, you can see I go down below, and that's so that when I do the fly cut on the backside to remove the carrier, I've got a little extra there. Okay. Okay, now I changed the stay down to like 6 inches, and that kept this down, but I could put this at well, let's do it here. Edit. This is what I'm running. I'm running 6,000 RPMs. This is a 3/8 cutter. It's only got an inch and maybe an inch and a quarter, inch and an eighth. It's a 1-inch flute length. Anyway, I'm going to run it at 4 thousandths per tooth. That's the geometry selected, rest machining. The height, this is where I set that bottom level so that it cuts 20 thou below the model bottom. And here, so optimal load 50 thousandths. That's all it's going to step over on each pass. Since I'm going up to 4, I've run it at that at 3 thou per tooth. I'm going to, instead of changing that up, I'm going to run it at 50 and 4 thou per tooth, and we'll see how it does. There's my maximum step down at 75, which puts it just below the shelf on the ear there. Stock to leave, I'm leaving 10 thousandths radially, but none axially. They come out plenty smooth enough and clean enough for a mounting surface. So, and I was having some issues anyway with the hole selection and everything. But anyway, what that does is that'll leave 10 thousandths along all the walls, so that I can come in here and clean up this wall, the inside. Well, we're not doing the inside yet. And the outside. So linking. There's the maximum stay down to 6 inches. That changed it picking up, because it was picking up here, coming back, dropping back down, cutting, picking up, coming over. It will now just move back and forth because it doesn't have anything to go around. It will still pick up over here when it has to go around the bump from the corner that it's cutting around. Okay. And you can change that by setting this to highest, and then it will move around, but there's really no point. It's not going to save me enough time to bother with. But let's see, lead in, lead out, ramp. Ramp isn't used on any of this, so there's the Toolpath again. So it'll come down 3/4 of an inch and it'll cut the entire level. Well, here we go. And it'll cut the entire level, and see, here it stays down, but it's picking up here because it has to go around that bump that it's cutting off. Okay, then it goes and cuts the 2 shelves, and then it comes down and cuts all the rest. And I have to do that because even though the cutter is long enough to reach the bottom, just barely, okay, it wouldn't be cutting at the very top here. So if I tried to take the whole cut at once, it wouldn't cut anything on that top 1/8 inch, and that would cause a lot of problems. So I step down and cut that, and then there's room for it to come down there. And I could possibly, I may take this tool and I may move it out another 1/8 of an inch just to give myself a little bit more leeway. Because if you look closely at this one, see the pattern of marks right here? Well, that's the toolpath it was running around here, and so since it was so close, it just kept dragging chips or something across it. Oh, and that actually, you know, that may be the scratch from the coolant nozzle. It's pretty pronounced though. Either way, it's not good, so I may have to reset up that tool. Okay, let's see, we already went through that one. Here's the inside pocket. It's a 2D adaptive. Okay. I'm running it at 6,000 RPM, 4 thou per tooth. Feed per revolution in the, while it's going down, should be 5 thou per revolution. It's a 3-flute tooth, so 3-flute cutter. So that's less than 2 thou per tooth on the end there. I don't have anything changed here. There's no point. Stock to leave, I'm going to leave 1 thou or 10 thou on the radial. Okay, and radial is always the side of the cutter. Axial is the bottom edge of the cutter. So axial's whatever's in the z-axis, and radial's typically the x and y. You know, it's not the z. Let's see here. And here I've changed my no engagement feed to 100. So when you look at those yellow lines where it's coming back, it feeds at whatever the, what did it say it was feeding at? It's feeding at 72 inches per minute. Okay. This means that once it's done with a cut, it'll feed at 100 inches back to the start of the next cut. 3 degrees on the ramp. You can change the diameter of how big the cutter goes in, how big of a circle it makes going in. And clearance height, 50 thou. That's how high the tool comes down to the top of the stock, and then starts ramping down. So if you leave that at like 0.5, you're going to be waiting quite a while for it to ramp down. So you can see right there, I've only got it. It only needs to ramp down 50 thou. You can leave that bigger if you want, and depending on the project you might want to, but up till now my ramps have been pretty darn slow, not very aggressive, so I wanted to bring it down closer because I don't want to sit there and wait, you know, a minute for it to cycle down on a 1/2 inch height there. Okay, let's see, 2D contour. That's pretty self-explanatory. I mean, everybody kind of knows that. It's a 2D contour. You select the bottom edges there. I'm using the same tool, so I'm running the same 6,000 RPMs, but I'm only running 3 thou per tooth. I just want to see if it's maybe a little smoother finish because it's going to be running a little bit slower. But And I did these at did these at 3 thou per tooth, I think. And I don't have any complaints at all with the finish on that. Anyway, there's that. So there's the stock, just selecting the edges, the heights, the bottom height, select the contours. Now I left 2 thousandths on here. I think I'm actually going to change that to 1. And the reason I'm doing that is that just, you're not going to notice the difference down in the actual corner, okay? So it'll smooth up the wall, but it'll keep the cutter, we'll leave it at 2. It'll keep the cutter basically 2 thou off the floor so that your tooling marks won't get run over, okay? And the adaptive clearing tooling marks are kind of cool looking. So why run a 3/8 inch flat spot all the way around the outside edge? I'd just as soon leave those cutting toolpaths there to see them. Okay, let's see here. Finish feed rate 54. Finish overlap. That's more for reference. I don't think I really had to do much in there. Maximum stay down 2 inches. On a contour, that's really nothing to... You're not going to change that. Whatever it comes up as. Okay. So let's see here. That was contour 1. So then I've got to... I must have deleted whatever contour 2 happened to be. Anyway, this is with a 1/2 inch cutter, 2 flute. And I'm doing this because it's longer. And I want the extra rigidity. So anyway, that 10 thou will help blend this in, because the last operation, you know, cleaned up this wall right here. And then this one with a 1/2 inch cutter is going to come around and take off 10 thousandths in here. So hopefully that'll blend these edges. And you can see on this one that it didn't blend it awesome, but close enough. And I don't remember if there was a reason for that or not, but okay, so let's check it here real quick. And, I'm running that one at 5900, 2 thou per tooth, trying to get it looking nice and finished and smooth. I've got bottom height at 0. I could run it down because, you know, I have like 20 thou there, but I'm not going to worry about it, because if it is right on the edge, I'm doing a chamfer on the opposite side. So if there's a sharp edge there or whatever, it's not going to matter. It'll get taken off. And on the other one too, I did the same thing. Finishing overlap. Okay, I put in 50 thousandths, and I'll show you that here in a second. Okay, so if you select 0 on that finish overlap, then these two arcs meet at the same point. Okay, and you can get a little mark on the finish there. So you can, I've been overlapping them like 30 thousandths or 50 thousandths in this case. I just want to see how it does. I don't remember if there's any on that one or marks on that or not, but okay, pretty simple for that one. Drilling. This is a 1/2 inch drill bit. I have it set up for 1500 RPMs, 3 thou per revolution, which is 1.5 thou per tooth, because the drill bit's got 2 flutes, 2 cutting edges. The height, I've got it set drill tip through the bottom, and hole bottom is what's selected. I could go all the way through to the stock bottom and do the same thing, have drill through the bottom 125 thousandths, and that's because, you know, on a drill bit of this size, there's quite a bit of tip there. And this is 135 degree split point. 118 degrees got a lot more. So if I didn't put that in there, it would just touch, it would just come down and cut to the end, and I'd have a closed hole. So you can do it 2 ways. You can either put a negative offset in here of 125, or you can tell it drill tip through the bottom and then write it in as a positive number, how far you want it to go. Pecking depth goes down 1/8 of an inch, and then it pops back up, and I have this set for Deep drilling full retract, because that hole is over 1 inch long. Minimum pecking depth 0.1. I don't remember if I even set those. I think they just came up like that. So if we look at it from the front again, okay, here you can see the green line. That's where the tip of the tool is. So there's the stock bottom. I guess I'm going far enough down. I didn't realize I was going to drill all the way through the model bottom. It's probably over drilling the other one right now. Oh, there it is. Oh, it's still pick drilling. Alright, then you can see it come through. So I don't need to go through quite as far. And you know, and it almost looks like it's taking it from the side. Oh, okay, well, just learned something there. Let's go back to the edit here on the heights. Drill tip through the bottom. That automatically accounts for putting the drill tip through the bottom. So I went 125 thou beyond that. So I really don't need to go anywhere near that far. Let's put that as 0.03, just to make sure that the wall of the flutes of my drill or whatever get down past the bottom of the hole there. Okay. Interesting. Yeah, see, so then not quite as far there. So if we do this again, and actually if we do that, it'll just show you. So there's the 30 thousandths now, right there on the side wall. Okay. If you guys are bored, just shut it off, because this is just archiving it for me, for the most part. If it helps, awesome. So let's see, this is now a 5/16 drill bit. I changed it from the 3/8 I was using, and because this 3/8 is longer than the Hammer taster, that I use for setting my offsets and work offsets and tools and everything like that. And I was having a hell of a time when I ran this drill. I couldn't go past that in a program because it would, the next tool I put in, when it did a tool change, it went up and it went above Z0 all the way at the top. And by doing that, it exceeded the soft limits. And I literally had to, what I ended up doing was shutting down Mach 3, starting it back up and everything, so it would clear everything out, because I don't know my G code well enough to be able to say, you know, whatever the G codes are, to go in and eliminate all the offsets and all that kind of crap. So the easiest thing for me to do was just to shut it off, reload the software, and start over on the next operation. So I would always have that 3/8 drill the very last operation, and then I could go through all that crap before I started the second operation. Well, what I decided to do was just to, I want a hole in the center so that I don't have to plunge it in with the end mill. It'll make it a whole lot easier, chip evacuation wise, everything like that, when I do the boring cycle on the next one, to have at least some kind of hole in there. So I'm doing it with a 5/16 because it's a stubby. That's what I have. I don't have a stubby 3/8 yet, so I think I used to. I think I killed them all. I don't know. Anyway, 1600 RPM, 3 thou per tooth. See, now here I have it set as hole bottom, offset, go through 80 thousandths. Now I know that's more than enough for the drill tip, because I took a rough measurement of how much point it has on it. Okay, so we'll look at that and you'll see it basically looks the same when we do it. And then let's see here. And I did this one as a full retract too, just because it's a smaller hole. On the other one, it was basically going down just over 3/8 of an inch, just under ½ an inch, and it was a 3/8 inch hole. So I wasn't too worried about it, whether it was considered deep drilling or not. This is 5/16. I figured, well, better safe than sorry. I'll consider it and give it full retract. There's the pecking depth, 78 thousandths. It picked that itself. So now if I come back here and we go do the thing, you can see there's my yellow mark. And it comes up red there because I haven't gone through all the steps, so it doesn't know that material's not supposed to be there. And the more you zoom in while you're doing a playback, the more it slows it down. Oh, that's all the further it went through. Oh, okay. Well, it must be, that must be a 118 degree tip. Mine's a 135, so I'm sure it's better, but so let's go ahead and edit that real quick. Go back to the height here and let's tell it negative 100 thou. There we go. Just broke through. It's going to get bored, so as long as it's close, it'll be just fine. Alright. And the 2D chamfer, yeah, see, I'm having an issue with one there where it's picking up. Yeah, see, it's making two different cuts. I don't know why. I had to change the hole sizes with a push-pull, and that seems to have screwed it up. On the chamfer here, I've got 6,000 and thou and a half per tooth. And since I'm using that 5/16 drill, I can actually chamfer the holes now that I couldn't really do before because that 3/8 inch drill was screwing everything up. There's got to be a way to do offsets like that, because sooner or later you're going to use a tool that's longer than your reference tool. But I'll worry about it later. I mean, because I'd easily have that problem if I was using drill chucks and drill bits. So then I guess then it becomes a matter of getting a tool setter and doing it off the machine. Okay, anyway, let's see. So the finishing overlap, I got 30 thousandths again. Now here you go. The chamfer width, that's the size of the chamfer itself. Okay. Now the chamfer tip offset, I have a 3/8 inch 0.375 chamfer tool. Okay, and it's a nice multi-flute, 4 flutes. Okay, so the tip offset is how far from the tip, okay, out. So, oh, I see, okay. 2 of the flutes don't come all the way to the point, 2 of them do. So I'm telling it to come off the center 100 thou. And, you know, I've got 0.375, half of that, 1.75, 1.85, whatever it is. I've easily got over 150 thou, but so I'm going 100 thou, and that way I come out here and I use further up the cutter. One, that picks up my surface speed a lot on the cutter because I'm not down close to the tip. The closer you get to the tip, the closer you get to 0 RPMs. Okay. So that's what I'm doing by having that 100 thou in there, is I'm offsetting it. And basically that makes it, instead of being right up on the, instead of being, you know, down here like this on the edge, setting it off 100 thou puts me more like that. Okay, and the reason I'm doing that is because coming into the walls here, I have a lot more overhang if I'm down here. I can get closer if I'm here. So by doing the 100 thou, that gets me further away from the tip and less sidewall, and now I can come down in here and do this chamfer clearance of 20 thousandths. And that is how close the side of the cutter, the side of the shaft, the shank, anyway, the side of the cutter comes to the wall. Okay, so with that turned down, you get a bit more of a pucker factor when the chamfer tool comes down right next to the wall there, but it also gives you a chamfer in closer to the wall. Okay. Save just slot rapid retract. Okay, I don't care about any of that. And if I okay, so you can see here how it looks like it's so far down in the hole, and that's because this line represents the tip of the tool. So up here, you know, it's down off the side. So we can probably get an angle on the tool coming down. So let's say right about there. And yeah, so I haven't removed all of the previous material, but you can see that gap right there. That's how close it is to the wall. That should be roughly my 20 thousandths, I think. So here you can see the chamfer gets up fairly close to the corner here. So if I had increased that 20 thou to 50 thou, it would have put it over here further and given me more clearance. Which I don't need. So that's what's going on with that. Okay. And if you do want to see that more accurately, come up here to setup, and you can actually just walk through all these till you get down to the chamfer, and you can watch it, or you can come back in. There you see it's actually done the chamfer cut there. If we back up one, we can play the chamfer and see and there it went down and did the hole. There we go. Okay, good enough for me. So let's look at setup 3 here, and you'll see my home, my orientation. The hell's that called? I don't remember. Anyway, I find it almost easier to come to a straight on axis, rotate it that way, and then you can grab the cube and kind of give it make it look like the home, but from the bottom side. I've already looked at the other, and doing it with the cube up here just keeps me from having to use the shift key. On solid edge, holding down the middle mouse button does a rotate instead of a pan. You have to hold the shift to pan. I like that way better. Maybe there's a way to change that in Fusion. I'd love to, because I get really tired of having to hold the shift key down to rotate stuff around when I want to see. Okay, So it looks kind of funky, kind of cattywampus there, where the home is, the orientation. And that is because so there you can see it. It's still referenced to that same point, even though, so in the first operation, the stock was flush with the side wall of this jaw. Okay, didn't matter, that was fine. When I flip it over, since I centered the cutouts in the jaws, still registered to this point, it accounts for the overhang, and that's why it looks like, that's why it is, the stock is overhung from the side of the jaw there. Now part of it too is that most of that stock is removed, but in order to do the first couple of moves, I forget who it was that said it, somebody on YouTube or Instagram, sorry man, I don't remember offhand, but they made a comment about when you have a big you know, when I flip this over, it's still got the carrier on here, and as you're fly cutting down and you get close, that cutter's coming around. Well, how thick is that carrier? You know, you get down to where it's got 10, 15, 20 thousandths left on there, and you're making a 20 thou cut. It comes in, and is it going to cut it? Is it going to push it? Is it going to ball it up? Is it going to slam it into the side here? What's it going to do? And so it's, with the plastic it was okay, because the plastic would just shatter, and oh, here we go. This is exactly what I'm talking about. Ignore that. That was another oops. But when you're coming around, you get down to the end there, you know, this stuff would just shear and break out of the way. Wasn't any big deal. But with aluminum or steel, much bigger deal. And the point they brought up was that, and so it made me realize, like, oh, I don't want to catch, you know, a 3,000th lip there or whatever, and have it ball up and break stuff and jam stuff and whatever. So what I'm doing here is, that's the fly cut's the second operation. I went in, and that's why the stock, that's why I have the whole stock here, is so that I can do this first adaptive clearing right down to the level there. Okay, yeah, and it is right there. So basically I'm taking away all of the excess. Now I could have had it just do all of this with the 3/8 cutter, but it wouldn't leave as nice a finish on the bottom. I'd still have to pull the fly cutter out to get a really nice smooth final surface. So by doing this, I saved myself a ton of time cutting all that material with a 3/8 end mill, but I just get that out of the way, and so now I'm left with okay, if you can see that the rest of the material is still there, but you can see just the profile, you know, it's the outline of the part just taller. So now when I go in with a fly cutter, whoops, which I can't do until I close that. Now when I go in with a fly cutter, I don't have to worry about those edges. I have a solid part. There's not going to be any flaps or anything like that. So this is going to step down, and I put a 20 thou facing, or a final finish pass down there. And the face is pretty much the same as the other, and I already talked about why I offset it the way I did, so the cutter marks don't end up right over the any mounting surfaces on the holes. So then this is a 2D adaptive clearing, just like the other one. Everything should be pretty much set up the same. 6,004 thou per tooth. There's my 1/4 inch around there. Stock to leave, 10 thou radial. I decided that instead of leaving 20 thou, I'd leave 10 thou on the profiles and just make it a little bit easier on the cutter there, maybe. I might be thinking backwards. Okay, so that's the 2D adapter. Then I got the contour. I think I did the same thing here with the height still. Oh, I took it down to 3 thou from the 4 thou, but at the heights here, yeah, see, I left it 2 thou off the bottom, so that I didn't leave tooling marks on that. And yeah, 30 thou on the overlap. Okay, now the biggest changes to this one is I have the 3/8 cutter. Oh, okay, never mind. When I tried to cut this day before yesterday with the short 3/8, and it went in and did a bore all the way down, but it didn't open it up to the final size, and so when I did 2 finishing passes on the first hole, it ended up hitting the shank above the flutes and didn't cut anything, so it didn't like that at all. So I'm using the 1/2 inch now. But anyway, so this one's going to come in, and if you really want to see your tool pass a little easier, you can come down here to this monitor looking piece here, visual style, come over to wireframe. Now you can get a much better idea what it looks like down inside that hole. Okay, I can still rotate it and see that when I get a flat bottom here, I'm poking through the bottom, which is what I want. I can go into edit and I can check that and see it's like I'm going 20 thou below the bottom, which I know I still have tons of room to the soft jaws there, so no big deal. 6,000, I'm only doing 1 thou per tooth. And then because it was I think I had it on 2 or 3 last time, and it went down pretty aggressively, and I wanted to slow it down a bit more and see if I could get some more accuracy. And then I've only got it at 2.5 thou per revolution. And so that should be okay there. And it's a bit harder to see, but let's see, where are we at here? Okay, but so you can see the bore in the center, and then you can see the finish passes, that outer circle. Okay, and I told it to do the finish pass twice, so it will it'll do the helical bore down, and then it'll pop up, it'll go back down, it'll do a cleanup cut, pop up, go down, and do a finish pass again. And I'm doing that to try to help make sure that the walls are parallel instead of getting any kind of taper in that hole. So as long as we're still on wireframe, basically this is the same. You can see that it's just bigger and longer. Okay, still using the same 2, using the finish pass and a repeat on it. So I'm really kind of hoping to get more accurate holes this time, and I'm expecting them to come out a hair small, because what I had to do because they came out 4/1000ths undersized when I did them on the last part. So what I was going to do was come in here and go to stock to leave and do a negative. I did a negative 4/1000ths, not thinking that that was on the wall. Well, the wall and the circle, that you got to twice that because that was radius. So when my holes came out, they came out 8/1000ths bigger. So this time I think what I'm going to do is I'm going to leave the stock to leave off. Once this operation's done, oh, and I still got to do the chamfer. Once this operation's done, then I can measure them. And if they're undersized, then I'll come back in and I have a specific post, and I'll just post these 2 operations with whatever I figure up to be the negative stock to leave and make those slightly bigger. Since it'll be these two in this operation, this part that changes, I don't have to worry about coming back and change them again before I run the next part. If I make the changes, post the process for just those two, run just those two to open those holes up on the machine a little bit, that will, then when I run the next part, all of it, that'll automatically make it to the new size. Okay. Oh, there's the chamfer. Good. I thought that was kind of strange that it wasn't there. So we'll come off the wire frame because that's a little harder to look at, especially with a chamfer. And there's the chamfer. And since I don't have any long tools like the 3/8 drill bit in there, I can come in and do the whole outside and all 4 holes. And I'm pretty sure that's set up the same way as the other one. 6,000, 1.5 per tooth. Oh, and I've only got the offset at 60 on this one. Especially if I was doing steel, I'd make a point to move this around so that I didn't wear out just one spot on my cutter. But here I don't have to worry about being quite up so close to the edge because I don't have any walls to get close to. Okay. God, I think that's about it. Now the question is whether to go to bed or run apart. So let's go ahead and post-process this because I've been all over this for a couple of hours now. So we'll do a post-process. I have it set up to show up as bracket op 1. There's my orientation note. I'm just using a generic Mach 3 mill. Seems to be working fine. Let's go into Dropbox, mill, 13-inch break. When I save it, it says there's already one there. I want to rewrite it. That way I don't end up with another one in there and, you know, I start putting too many names in there. I start getting confused which one's the current one. Now one thing I do all over the place. I come all the way down to the bottom here and I put in an M5. And what that does is that stops my spindle before it does all the homing and everything and gets to the M30 down here at the end. It's nicer to me just to have the spindle shut off sooner. The M9, that should shut off the coolant, which I don't have the coolant running anyway. And then this G28, okay, that tells it to go home, and G91, if I remember right, is an incremental move. And it's telling it an incremental move of Z0. It really doesn't make a great deal of sense. And then the G28 X0 Y0, that would put my X-axis all the way back to home over on one side, which starts getting too close to the doors on my chip curtain. And so I come in, I put in that M5 to stop the spindle, and I come in and I take out that X. And so now when it finishes, the table just moves all the way forward toward me so I can unload the part easier. I don't know how to go in and change anything in the post-processor to have it do that automatically. Might learn that someday, but for right now this is good enough. So that put it right into Dropbox, so now I can pull that up on Dropbox over on my mill. And let's process this, post-process this one too. Up to, right over it. Do the same thing here. Put in M5 and delete the X0. Save it. And it's good to go. Now, I'll just do this here real quick. This is what I was doing yesterday when I was playing with the hole sizes, okay? I would just hold down Control, you select the two, and then post-process. And then I came in and I changed the name to 0.25. to differentiate it, and that way it didn't write over my second op that I just got done saving. So I come in now, I have one here from before. This is different, that one's invalid, really doesn't matter, so you know, I could save over it and it has the current sizes. Doesn't really matter. You can see the bar is longer here, there's not near as much code, but I can still go in and do the same M5 and get rid of the X0. And I don't expect to use this. I'm really hoping that the holes come out right, but I'll have to repost this again if I do have to come in and edit those if they come out too small. Well, battery's about dead too. I've been talking way too much.